Cool. Okay, so we're going to focus on the software development lifecycle, but a specific part of it, which is what I introduced yesterday. This first part up here, requirements into user stories, and then into a representative domain model, the yellow and green sections up here. So maybe as a fun way to think about this, each of you, I'm gonna say something, and I want you to think about the steps needed to do this, right? And just write out a bunch of steps on a post-it note and whack it on that on the whiteboard down here. Just to get post-it note steps 1 to however many you think you need. And the task is make a lasagna. All right, make a lasagna. This task might be foreign to you if it's something that you don't cook. But let's see how far we get with this analogy. The task is make a lasagna. What do you need to do? What steps do you take? So write them out and then whack them on wherever you get to. It doesn't really matter. And whack them on the mirror board. Yep, do that have a think for a good 2 minutes. I'll be right back. Okay, 1 more minute. No more than that. Some of these are fantastic. Eat, question mark. So you might not have thought this morning, but we're having an impromptu lesson on how to make lasagna. Peer-to-peer learning. It's great. Okay, so the point of this exercise is to give you a sense that sort of development life cycles happen in almost any task situation. All right, so you instinctively know how to take some vague, fuzzy sort of requirement to make lasagna, break it down into a set of discrete tasks. And even for each task, you have sort of a clear picture of what the domain looks like. So for example, if I look at this, sort of, the one directly in the middle, this one here, let me make it really big. By ingredients, everyone understands like what an ingredient is, what you need to do to buy it, and the sort of discrete things. You know what dough is. Every task has almost for everyone, because we've lived and breathed and existed as human beings in this environment for such a long time. We know how to do this, and so we need to apply a same kind of abstract process where we take a requirement and we convert it into a series of steps. And for each step, we have to think about what needs to happen to carry it out. The same process happens for software and how we take it and break it into small things and know what we need to do to carry it out. So if anything, cooking is actually a really fantastic analogy for lots of specific parts of software development. But just as a high level, like a software development lifecycle, maybe like a fancy name, but it's still just how do you break things down to small steps and then do it, all right? How do you take it all the way to eating it, in this case, releasing software? When I think about this part of breaking stories or requirements down into small parts, one way we can help sort of accelerate this process, think about it, is developing, to begin with, like a structure to it. So if I share my screen very quickly, and this is something I should share in the co-op channel. Oh, no, not USAC. Is we're going to focus on one part of this this morning, of how do we create these small steps and build up a picture of how we can do this. So two specific objectives this morning: give the structure of a user story, so we're familiar with how some of these user stories are in software development, and then extract a domain model from user stories. So as you've just done in your sort of lasagna example, you took make a lasagna and you broke it down into a set of specific tasks, and you can think of those as user stories, things that you need to do. There's, you can read the sort of brief here that I wrote. It describes one thing. Where possible, it should be one discrete thing. And it's called a user story because it should be from the perspective of someone who's actually using your program or using your feature or using the thing that you're doing. Now, at the moment, the user is also us, right, as developers. We haven't created any interfaces yet. You're not playing with your features through a mobile application or a web interface or a command line at the moment. You're running it as a developer, either sort of directly as a file that you run through Node, or in your Node REPL that you can sort of load the file and create your objects and play around with it. As we progress later in the course, user stories become more important to sort of identify what users need to do on your application. But we're ignoring that for the moment. First, the user story is important to remember that it is from the perspective of someone else using your program. So a lot of your time you'll be thinking about how do you convert these requirements into just tasks for you to do. Sometimes those tasks will be given to you, sometimes you have to clarify them, but that is a lot of useful work to be done. So one way we can think about breaking these tasks into something that we can carry out and form tests is to think about objects and messages. In object-oriented program or object-oriented programming, objects and messages form like the bread and butter of how we want to organize our systems. So an object describes something in the system, and messages how we get data from one place to another. So if we have a look at this type of user story, you can see 3 lines in it. The first line, the first line, as a user, describes the person who's going to be using it. And at the moment, we can kind of roughly ignore this because, again, we're not writing applications that have a real interface at the moment. There's some context, so I can find a specific cohort. And then there's like an action that needs to be taken, some result. I want to search a list of all cohorts by a cohort name. Now, below you can see two sort of representations, one with a little bit more detail. Now, this is only just one representation. There's no right answer here. It's just one way of thinking about converting these words into something that is a little bit more in object-oriented programming, objects and messages. And so you might want to pick out, when you go through this, that you have some like some nouns, cohorts as like an object that feels like it could be a class. And maybe there's some verbs that you can think about as messages for those objects. So one way you could represent this information is to think about this as objects and messages and just whack it in a table correspondingly. So a cohort would have a name method, and a cohort list would have a search by cohort name method. Okay, not the only way, but it might be one way you could go about this. Right? And the idea is trying to figure out how can we go from some requirements to a user story to objects and messages to acceptance criteria, tests, and then writing code. How can we do this in a structured way? At the moment, like your lasagna, you can do it all instinctively when it's something that you very much know. At the moment, a lot of this is very abstract, so we have to find a way to a process for us to follow. So you might want to, if you're like, hey, this feels like it's a reasonable representation, then you might want to add a little bit more information to it. How could this work? Right? Imagining some of these interactions, and maybe diagramming it out. Maybe your cohort needs to have a property name that will store as a string, and that the message just returns that string. And the output tells me what it's going to do. Maybe my cohort list has the search by cohort name method. It needs to store inside of it an array of cohorts, and when I search through it, it will return to me a cohort. This is one possible implementation of this. Now, the great thing about this, if we start imagining this table, the next step, which we won't get to today, but the next step becomes very easy when we write our first test. We create a cohort list object, we run our search by cohort name string method, and we expect the output to be a cohort. And we can assert that that thing happens. And so we're trying to find ways to move smoothly through some vague requirements into objects and messages to a test that asserts on the value. So again, there isn't one specific right answer to this question. You might have a different way of modeling this, and modeling is something that we'll get better at. Modeling takes some information and tries to demonstrate it simply, choosing one or two things to highlight. In this case, this model represents objects and messages. So let me pause if you have any questions at the moment about that process of looking through this username, user story, sorry, identifying parts of it that we think look like objects and parts of it that look like messages, and then putting them into a table. How does that look to you at the moment? Some thumbs up. Yeah, cool. So what I want for you all to do, and I'll pair you up in just a second, is to have a go yourselves at a set of 2 user stories. You can again do this one if you'd like, and just to have a feel for it. But your task this morning is to take these 2 user stories and create a functional representation of them. So think about objects and messages first, and then add properties and what you want your messages to produce. So here are your 2 user stories. As a supermarket shopper, so I can buy items, I'd like to add items to my basket. So first of all, write down all the nouns and verbs in the user stories, similar to how we looked through this, and pick out things that could be objects and messages and put them into a table. Then extend your table and make it a functional representation by adding properties and function outputs. Then play around with how you want your objects to work with each other. And then once you're done, share it in the cohort channel. Well, let's put it on the mirror board for now. Let's put it on the mirror board, whatever your table is. And then we'll gather back in about half an hour to see how we got on. If you race through it, feel free to have a look at the further work. Cool. So just quick Q&A. Any questions about these instructions, about what I'm going to do, what you're going to do for the next half an hour? Cool. Let's stay in the pairs that you were in. Should we do that? Yeah, let's do that. No, I'm going to, nope. I'm going to put you into Zoom breakout rooms. So let me pause the share, then go breakout rooms. Assign automatically. I want some. Okay, better open all the rooms. Last moment to ask any questions about what you can spend the next half hour doing. Sweet. All right. So again, say hi to each other. Good morning. All the lovely stuff, and then have a go at the instructions. Work on the Miro board, or feel free to work wherever. But then just like copy an image or wherever you want and put it on the Miro board, so we can all see what we're doing. Sound good? Sweet. Cool. Go. Cool, we should all be back in a second. Cool. All right, take a second to think about how, when over the past half round, just maybe share any questions that you have or any reflections on the mirror board just below. Zoom in a little bit because we zoomed out a lot. How to go? Any questions? Any like confusions? What felt difficult or what felt easy? And sometimes that's an interesting way to approach a reflection.
Sorry, are you waiting for someone to say something? Or
you, Jamie? Yes. I wanted you to tell me more about.
I didn't mean to volunteer myself.
Whatever's lying against that wall on to your left. Looks like a whiteboard.
There's two whiteboards. There's nothing on them, but we wrote it on.
Shame. Whiteboards are meant to be marked up, right?
Yeah, but I don't have any projects like that.
No, we just.
I was working with Josh. I don't know how he felt about it because we didn't get time to like discuss it afterwards. But I feel like it was quite easy. Maybe because the examples were simple. And how like you broke down the points of like how you're going to do it made it easy. But nice.
Good. It should feel when we're workshopping the skill, it should feel easy, so we can practice it, and then when we apply it in new domains, that's when it feels like it'll be useful. And then not just that, but specifically with domain models, the real test comes when we convert it into test code and then source code. That's when we'll really understand whether our domain models are useful. And sometimes that will cause us to change them, update them, but we haven't got to that stage yet. So there's no real good test at the moment for like how good our domain models are apart from experience. But as long as we practice it now, and then when you all split up into your pairs for the pair work, that's when you'll actually start writing tests and then writing code to pass them, and you'll figure out is your domain model useful? If not, do you need to change it? And emerging designs are important. So whatever you start with is not necessarily a thing that you'll end up with, and frequently it changes a lot by the time you get there. But it's a way of thinking rather than like a finished model. Okay, so we have some questions or some reflections. Nice to try different side programming. How do we use it in the real world? Cool. This is a really good technique just to align with your pair partner or align with your team about how you're thinking about something. Sometimes when you're pairing, you can talk verbally about a domain model. Sometimes you don't need to write it all out, but frequently it's a really good way to document a way of thinking. and document your approach to solving something. So at the moment, for the next few weeks, where possible, use these kinds of tables, and you can add more columns to them to keep your thinking structured. Just know that they will change, and it's okay to change these domain models. There are different ways to represent a domain model. At the moment, a table is useful, and you can find different ways to represent that information. A model is simply a representation of some information, usually more simple, and highlighting one or two things, or inversely, not highlighting others. And we'll have a look at a couple more this week and next. Okay, so what is the difference between message and property? So let's take, for example, the basket. The basket might have a property of an array, storing items. So that's like a property of the basket would be a list of items. And you think about it perhaps in types. What type do you want it? Do you want it to be a string? Do you want it to be an array? Do you want it to be something else? Convenient structure at the moment to hold items is an array. So we'll be using, you might want to use that for that property. So property is just thinking about what values you want your object to have, to be responsible for. Whereas a message at the moment is a way to think about functions and methods. We use those names interchangeably. A function is a useful way to thinking about inputs and outputs. You give a function an input and it gives you an output, or sometimes multiple outputs. But when we use the word messages, it's really trying to convey some more information about how objects talk to each other. So it's an OOP thing. It's an object-oriented programming thing when we talk about objects and messages. But messages are in effect methods. For example, the basket might have an add item message where we ask it to add something. So there's frequently a way of thinking about messages where we ask objects to do things, we don't tell them to do it. All right, telling it to do it would be like asking, like going into the array and mutating it directly rather than having a function to represent that. So we ask the basket to add the item. It's a subtle way of thinking about it, but you could, if you wanted to make it simpler, just use methods or functions rather than messages, if that makes it simpler for you. Does that help with the difference between message and property? Perhaps, yeah. Yeah, okay, cool. Usually that would be probably targeted to the person who wanted that explanation. If that helps, let me know. Sometimes it's difficult to separate out the different messages and properties. They seem similar. So I think that might be hopefully also answered in this question. So think of it as what values do you want your objects to have, and they'll be stored as properties on the object, and what do you want your object to do. So in this case, we want it to add an item, or we want it to check a basket, what other people have had here. You want your item to have a name. Those would be messages that give you back a result. You ask it to execute something, you ask it to do something, and it gives you back a value. Property is just values. Think of it as just values that the object will have. Property is not the only way we can store this information at the moment, but we're using that at the moment. Does that help? Yeah, basket has items, that will be the property. If you wanted to return something or do something, you would use a message, say list items, for example. That would then look through the array and print out everything or return everything in the array. So another way we might remember thinking about objects as both bundling behavior and state. Behavior would be like the messages that an object has, and the state would be the properties or values an object has. There's another way of thinking about it in terms of behavior and state in an object. Cool. Sometimes it can be fun to add a column for context. So if a message has multiple outputs, so I'm looking at the one just above this, the healthy shopper table, just because it's right there. And I see in throw error if full, there's something there that has like a certain condition. So sometimes you might want to add more columns with different, for the same message, but for different contexts. So if you're trying to add an item, it works. If you're trying to add an item and if it's full, it shouldn't work. Those would be two different contexts. Just a way to help maybe structure thinking. But anyway, again, domain models only so far as you find it useful. So find whatever way that helps give some structure to your thinking. If we create an object for our items, how does it interact with our basket object? Do you create a new instance for each individual item? How do you add this to the basket? So these are all things that will come out when you try and actually do this. Right? So there's no right answer to this question, or there's no, I could probably give you a few different ways that could happen. But at this point, then you could either go play and have a look in your node REPL, just like play around with doing some things, or just write your first test and see how it goes. A lot of it at the moment is, our knowledge of like how some of these objects will interact is not yet developed. So sometimes the only way to do this is just to go out and practice it and play around with how these things would work. And then if you realize your domain model is not accurate, go up and update it. And that's expected, all right? I just want to make sure you all know that these domain models at the moment will likely change. You might want to strip things out, make it better, totally change them. And that happens as part of the design process. As long as we're thinking about objects and messages and then outputs of functions, it will really help you get from a user story to writing your first test and then passing it. Any other thoughts or questions at the moment on this exercise? Cool. So the expected result from everyone are these tables, which is great. Great to see. And you're about to be able to test them yourselves when we go to the paired work. This is probably starting in just a few minutes. If I go back to, I forgot to resume the recording. Jesus. Anyway, we'll just record that demo part. What was I going to say? Okay, so if I go back to the workshop, the two learning objectives are give the structure of a user story. So we're now familiar to begin with the structure of how a user story works, and then be able to extract a domain model, a functional representation of the user stories in tables. So that's the point of this session, because you're going to be using this in your pair partners in just a moment. So if I share my screen, screen sharing. Am I screen sharing? You can see my screen, yes? Sweet. This is what you are going to be working on in pairs this week. So anytime you're not in a group workshop or doing individual work, and this is what you'll be pairing on. Our sort of Bob's Bagels shop. And this is credit to our conversation about bagels the other day. Made me very hungry. So all you're going to be given is a set of user stories. I've roughly organized them into 3 parts. And essentially all you're going to be doing in your pairs is looking at a set of user stories. So for example, part 1, this is very similar to what you've just done, organizing them into a functional representation of these using a table as much as you'd like with different columns. And then using them to write your first tests and making them pass. And then you'll be doing that again 3 times. And once you've got to the end, I'll just keep adding more user stories as the week goes by. So the part that is going to be new is how to move from your tables to writing your first test using your test framework that you built yesterday. So at a minimal level, all you need is that one function to assert the two things are the same. But given that you have your outputs, you should be able to find that you can set up your first test to have a new basket, and then choose your first method that you want to write a test for, add item to basket, for example, and assert that whatever you've understood to be your output is the thing that happens. And then you can set up your test accordingly. Once it's failing, then you go through, as we've done here. Once you have your first failing test case, you make it pass by writing your source code, make any changes, and then you go back to your domain model and pick out the next method that you want to write a test for. So that domain model that you've come up with serves as the way to help you understand when you're done. And you'll keep expanding or updating your domain model as the user stories go by in this challenge. So each part, you might need to go and rejig your domain model. It expands with more things, and you might need to then go back and update tests and update your code, and that's a part of the normal process. So your first test might look like creating an instance of a basket, calling the add method, passing an item, and asserting that there's an item in the array, or that the array has one item, however you want to do that. You have to make some choices, thinking about in your pair partner how you want to test that your add item works. And once that test is failing, then you write code to make it pass. Then you move on to the next user story. Cool. All right, have a go. And then when we let's dive into pairs straight away today, and then tomorrow we can just do pairing in the afternoon. Have a go, because I want to unearth any sort of confusions by this afternoon when we have our check-in at 2. And then tomorrow morning I'll demonstrate doing probably just the first 2, depending on where you all get to tomorrow. So you'll see me do it.
Sorry, did you say we're diving straight into pairs?
Yep. Have a quick break, because I know we've been on working straight since this morning. Yeah, have a quick break, and then a get together, and thinking about how you convert this into a domain model in a table, and then writing your first test. And that's the part that you'll probably spend most of your time on, thinking about how do you write your first test, and then making it pass. Any questions before I end this session? Same pairs as yesterday. Everyone, give me a thumbs up if you understand what you're about to start doing. Sweet, cool. Otherwise, I'll see you back at 2 p.m. or 2:20, and I'll be on Discord if you need any help. All right. Awesome. Enjoy.